In this video, we are going to go over every single area of mathematics. So what I have done is I have created 8 categories, and you can take any math subject in the world and you can fit them into one of these categories. Now, there are different categorizations of mathematics. Typically, people do it by saying, okay, this is pure math and this is applied math. I decided not to do that for a couple of reasons. One, the stacks of books would be huge and they would reach the ceiling. Two, I think this gives you a better idea of the different subject areas. And that's my goal of making this video. A lot of people, when they first see math, they're frustrated by it because it is challenging, right? Math is hard. And when things are hard, well, it's hard, right? We want to give up. But it's okay. Once you realize that math is hard and that there's different types of math, well, that kind of makes you like it more. And people tend to like what they're good at. So if you like math and you're really interested in it, then chances are you can become very, very good at it. So this video will give you an overview of the specific subjects. So under each category, like for example, here is Foundations of Mathematics. Like under this category, there's a bunch of subjects, okay? There's all kinds of math that falls into that category. I put algebra there as well. Some basic number theory, logic, sets. Algebra and Structures, same thing. A bunch of stuff falls into this category. You've got like linear algebra that falls into that category as well. Geometry and topology, this one's pretty self-explanatory. It's geometry and topology, but there's some specific types of topology that are a little more advanced, like algebraic topology, which I decided to put in this category here. Discrete mathematics and combinatorics, this is the kind of thing you would see like as a computer science major. Computer science majors typically have to take discrete math. And this is an entire book on combinatorics, which is pretty cool. Oh, by the way, I'll leave links to some of these books in the description of this video. Not all of them, it's too many, and some of them are rare and stuff. You won't be able to find them, but I'll leave like some good ones for you in case you want to pick up some books and learn some of these cool topics. This is a monumental stack, right? Look at this. This is completely ridiculous. This is analysis and calculus. So the reason it's so high is because I decided to put in a bunch of good calculus books, and then complex analysis is here, real analysis is here, differential equations, Fourier series, ordinary differential equations. So a bunch of stuff falls into this Hilbert spaces, right? Tons of stuff. Applied math and modeling, here's where the stack could really reach the ceiling, right? But I got tired of looking for books. I have thousands of books and they're scattered everywhere. They're in stacks just like this. And so basically here I put physics, and we've got some engineering and some other topics as well. Probability and statistics, this is really useful stuff, and I don't think people care about it enough. So I've got a couple different options here for learning stats, some that are just like general stats, and some are for engineers, and some are for mathematicians. So different stats books with different audiences. Advanced topics and frontiers, I could have put a lot of these books in this pile, but I decided, no, let me just pick 2 really weird books that these are things you've never ever heard of probably. It's like super advanced. And on the bottom here, I have hidden that super secret book, which I want to show you at the end of this video because it's awesome. It's really, really awesome. And if you've watched my videos before, well, I'll tell you, I interviewed the author here on the channel, and he's super awesome. So yeah, his book is down there. We'll talk about that at the end. All right, so I guess we're going to get started now. I'm going to go through here and just go through each stack. I'm going to start with Foundations of Mathematics and then just keep going. So feel free to fast forward this video, like, skip ahead if you want to jump to a specific area. But yeah, after watching this, you should have a really, really good idea of the different areas. And I'll also give you the prereqs as I go through. All right, let's go ahead and get started right away. All right, let's start with Foundations of Mathematics. So we're just going to go through each book, and I'm just going to give you the prereqs and what I think about the subject. All right, so Foundations of Mathematics. So the first book we have here is one on logic. It's called Introduction to Logic. It's by Patrick Supps. So this is a book that in theory you could use to learn logic. So logic in mathematics is really important. Proof writing is based on logic. And so typically in foundational math, you do a lot of logic. You learn about sets, which are collections of objects. And then you do a lot of baby proofs, like easier proofs with sets and stuff. So a book like this will teach you logic. This is a book on logic. There aren't that many books on logic compared to like calculus books. And logic books vary from one book to the other. So one logic book can be very different from another logic book. It just depends on the book. Next up, we have a book on arithmetic, and I actually have several books on arithmetic, but I wanted to show you, that's a topic, right? Modern arithmetic through discovery. So I feel like this is not a course that's taught in college today. There's not really like arithmetic courses. I wanted to include this one because this is an amazing book. So if you have to get one foundational book, I think this is the one that will affect your life in the most positive way ever. This one's called How to Prove It, a Structured Approach, and it's written by Daniel Vellman. The reason I feel that this book will be more life-changing for you than any of these books here, actually than probably any book here, except maybe that book at the end, this will teach you to write proofs. Once you know how to write proofs, you can do a lot more of the advanced stuff like that you see here in these other, more advanced categories, right? So very good book. He explains things really well, and yeah, I can't say enough good things about this book. This book I bought because people kept leaving comments about it, and I did not want to buy it because I remember at the time I was like, I really got to stop buying books. I don't have any room. They're all over the floor. It's ridiculous. And then people were like, oh, you should get it, and I got it, and I read a chapter or two, and I was like, wow, so good. Number theory. I know number theory can go, maybe in some other categories, but I wanted to include it here. So the basics of numbers and the theory of divisibility, stuff like that, prime numbers, I felt like that should be foundational. Set theory, this is probably the most famous set theory book ever written. It's the one by Felix Hausdorff. So if you know topology, you know about Hausdorff spaces. This is the same Felix Hausdorff after which Hausdorff spaces, also known as T2 spaces, are named. I have to smell it, I'm sorry. This is a first edition. Set theory, it's a little bit hardcore. The prereq for this one, by the way, I think you really should know how to write proofs before jumping into this. Same thing with number theory, sorry, I forgot to tell you. So proof writing, right? That's gonna be a big prereq for a lot of things, okay, for a lot of things. The logic book you can just jump into. This you can jump into, right? You can just get this and read it and learn. You don't need really any prereqs other than like an amazing willpower because it is hard. It is hard. That one's a mistake. I have a book there that is not supposed to be in that pile. College Algebra by Blitzer. I decided to include algebra and foundations because you do need algebra in order to progress, right? You have to learn algebra so that you can take calculus. This is a book that I've used to teach college algebra in college for years. So it's a great book and you can use it for self-study. It's got answers in the back of the book. So this is mainly like quadratic equations, graphing parabolas, you've got some stuff with polynomials, so systems of equations. Here's some graphs, as you can see. Yeah, I gotta smell this, I'm sorry. It smells amazing. If you're really just getting started, pre-algebra, I mean, this is foundational. This is basic stuff like, converting fractions to decimals, stuff like that. Really basic mathematics is pre-algebra. Intermediate algebra, this one comes after pre-algebra, but before college algebra. So the order is pre-algebra, intermediate, college. All algebra though, they're all algebra books. And yet another algebra book in foundations, and you need to know algebra. This is actually a pre-calculus book. This is a book I've used to teach pre-calculus, to teach trigonometry, and to teach a combined course, a pre-calc trig combo course, which is way harder, in college. And this is a great book. This basically has all the information that the lesser books have, like that the pre-algebra books, this has everything the college algebra book has, I mean. So you can just basically, books are falling here. If you already know some algebra, you can skip Blitzer and just get this one. That's just my take. Anyways, that's the foundational stuff, right? So you can see it's just mostly algebra, a little number theory, proof writing, sets. That's like the foundations of mathematics. And I could have included more books on proof writing. I have tons. I don't know why I did. I was more focused on making sure everything went in the right category. And are these the best categories, right? Because again, you can categorize things differently and there is a lot of overlap. Let's go to one of my favorite categories, which is algebra and structures next. This is actually really fun to go like not in order because like we have like advanced books, then we have easy books. So algebra and structures, this is a great category. This book here teaches you abstract algebra. This is a more advanced book. This is an incredible book because it contains so much content. I bought this as a reference. My biggest regret is buying it used because look, my copy is not in good condition. I really I'm gonna buy a new copy someday. Look, see, it's falling apart. But it's a wonderful book. This has things in it that are just priceless. For example, even in graduate school, I was using this when I was studying semi-direct products. So very useful. You can use it to learn abstract algebra. The prereq for this is knowing how to write proofs, but I don't think that this is the best beginner book, but it's a book worth having if you're serious about learning abstract algebra. So that's a subject that covers groups, rings, fields, modules. You're looking at algebraic structures. Then you have linear algebra. Here you're dealing with matrices, linear maps, systems of equations. Also, this book here is computational based, so it's going to have some proofs, but it's not like a proof-based linear algebra book. So usually you have two types of linear algebra books. You've got like the computational ones, and then you've got the proof-based ones. But it's all linear algebra, and it falls under Algebra and Structures. An actual book called Algebraic Structures and Matrices. Galois theory, so this falls under again, the Algebra and Structures category. Galois theory is more advanced. You have to know some field theory to get there. Field theory, you learn in a book like this. This actually has Galois theory in it as well. This is an amazing book, again, for the content. So I am going to buy one at some point. Another legendary book, A Survey of Modern Algebra by Burkhoff and McLean. My favorite abstract algebra book, this is the one I learned abstract algebra with. I read this entire book, and my only complaint about this book is that it didn't have enough information. I got to smell it. Oh, it's so good, so good, so good. But it's a great little book, super beginner friendly. Highly recommend getting this one. If you're going to get one, this is probably the easiest one. A linear algebra book that is proof-based. This is the one by Friedberg. So this is very similar to the one we looked at earlier, the one here. It's a glare, sorry, by Larson and Edwards, but this is harder. Okay, this has proofs. It's way more rigorous. So this is usually used for a second course, okay, in linear algebra. Kind of nice. Great book. It's like, I feel like it's like a necessary evil. Like it's a good book, but it's hard. Like it just, I don't know. I had a really hard time in that class when I was a student. But it's a good book. I used it even as a grad student as a reference, and I've looked up stuff. Really good for beginners, though. This one's better for beginners than any of the ones I'm showing you. It's another linear algebra book by Anton. And then we have one here that just has more information. Look how thick that is, by Shanann Kincaid. So basically, this category is just algebra and linear algebra. So let's just, I can scoot this over, and let's take a look here at this category here. This is the geometry and topology category. So let's see what we got. This is the general topology book. So to learn topology, you have to know proofwriting, and you have to be good at it. So like just being okay is not enough, right? In topology, you study continuous functions that take topological spaces to other topological spaces, and you have like properties that are preserved under homeomorphisms, and they're called topological properties, and you study those, and yeah, and you can keep going. Here's more topology. This is topology with an introduction with application, to topological groups. So this is more specific. I've seen topological groups in an online book called Topology Without Tears. It's free. So yeah. And then we have geometry, but look how hardcore. It's differential geometry. So it's not in order, right? So normally you do like, okay, step one. No. So to do this, you have to know calculus. You have to know how to write proofs. This is tough. Differential geometry, you have to know a lot. Here's a lost subject you've probably never seen. Plane and spherical trigonometry, right? That's pretty cool. So spherical trigonometry is no longer taught. So I have this theory. I think it was used a lot, and it was taught a lot during the World War II era. And I know that during the war, I think they used a lot of this stuff. So it was taught a lot back then. Like, what's the copyright on this? Let's see. Yeah, see, 1950, so it's after World War II. All the ones I have are older. I don't have any newer books on spherical trigonometry. It's like they don't exist. So if anyone out there was really into it and wants to write a book, there's a hole in the market for spherical trigonometry books. Kind of an interesting fact. Let's keep going. We've got, whoops, so many books, they're falling over. So here we have Lectures in Projective Geometry. This is a very advanced book. This came actually from a private collection. This book belonged to a man named Augustus Prince. He was the first black radar man in the US Navy, and he was a nuclear physicist who worked at Brookhaven National Laboratory. How do I know all this? I collect books. I'm a collector, right? So I have a lot of math books, and so the history of the book matters. And so I was able to pick up some books from his collection. He passed away several years ago. So really sad. Yeah, really, really sad. All right. Geometry, an actual book on geometry, and it's comprehensive. This one's good because it's affordable, and you learn a lot. So that falls into this category. Another differential geometry book. This one is really fun. This one has solutions to every proof in the back of the book. Let me show you. Check this out. This one but you might say, oh, so it's easy. I can learn. I wouldn't go that far. Just because you have the answers doesn't mean it's easy. So it's still really tough. Again, for topology, you really, ideally you want to have some advanced calculus and analysis. We haven't even gotten there yet, but you want to have like proof writing in other classes like abstract algebra, real analysis, and then take topology. So yeah, this one has answers in the back. I love this book, and it's affordable too. It's probably one of the best topology books you can buy right here, and it's like not even expensive. Highly recommend that one. Very famous book, Algebraic Topology by Alan Hatcher. Extremely hard. And another algebraic topology book, again, extremely, extremely difficult. Let's keep going here because we still have like a bunch of stacks to go through. So let's go to this stack here. I'm just going to set the camera down and let's keep going. So this stack here, it's not a big stack, even though I have a gazillion books on discrete math. So discrete math is something that computer science majors take. So if you go to college today and you get a computer science degree, this is what a class you would take, okay? And combinatorics is also a class a math major could take as well. And then graph theory. So that's what you have here. Discrete math, combinatorics, and graph theory. That's what falls under here. So applied combinatorics. This is one of the few books I have on actual just combinatorics. There's not that many that exist, right? So that's the thing. This is a fun one. Discrete mathematics in computer science. I love the name and the cover. So discrete math covers a bunch of topics, by the way. So let me just show you what it covers so you kind of get an idea. And the prereq for this, so the prereq for discrete math, at most colleges, they'll say, oh, you have to take Calc 2 before you take discrete math, right? And I think they do that just because they want you to like be decent at math, not because there's actually anything you need from those classes. Although sometimes there's examples that use calculus, but not many. So it starts with logic, which again, this could have fallen under foundational, right? I could have done that. There is some overlap. So if you take the intersection of these categories, in many cases that intersection is not empty. That's because there's a lot of relationships in mathematics between fields, right? So it's really impossible to break them up into categories like that. Binary relations, functions, infinite sets, algebras. Yeah, this one doesn't have as much as some of the other ones. Here's a book on combinatorics. This one's really hardcore. And then this book, this one has more content than the ones this is the best one for beginners right here. This is the best discrete math book for beginners. And you can use this for a graph theory course, a combinatorics course, or a discrete math course. I took a course that was called Combinatorics and Graph Theory, and I used one of these books. So you could use it for one of those. But let me look at the topics here to show you, because if you're into computer science, you'll want to see it's got number theory. We talked about that already. So this is really foundational stuff, right? Induction. But I wanted to give it a separate category because it's important. Computer science is important, right? I'm using a technology to make this video. Like, yeah, computer science is extremely important. See, there's the graph theory. Yeah, I think it deserves its own category at this point, right? It really does. It really does. All right, let's keep going. Both of these stacks of books contain analysis and calculus books. So that's a lot of books, right? And the reason there's so many books, and I could have added so many more, is that there's a lot of different subjects that live inside this analysis and calculus category. So what is calculus? People will say that calculus is the mathematics of change, and that's a pretty true statement. Typically in calculus, you start by learning what's called limits. And basically it's the idea of getting infinitely close to something, but never actually getting there. And a limit kind of, that's what it defines. It allows you to get close to something. It allows functions to get really close to numbers when x values get really close to numbers. What happens to the function value, when x gets really close to 2, right? And what happens to the function value when x gets infinitely close to 2, right? That's the idea of a limit. So that's defined precisely via a definition with inequalities and stuff. And so once you have limits, you can define derivatives. Derivatives basically describe rates of change. So like if you have a function that tells you the temperature, well, the derivative of that function is the rate of change of the temperature, right? Or if you have a graph, the derivative is going to be the slope at that particular point where you find the derivative, assuming it exists. So all kinds of stuff, I can talk about it forever, but this book is wonderful because this book does not require any trigonometry. I've used this book to teach a certain class in college, and the prereq for that class is only college algebra. So this is a very special book because there's not many books like this in the world that allow you to learn calculus without knowing trig. Now, you should know trig, but it's just a book worth getting if you can get a copy. I'll leave a link in the description so you can check it out. This is a calculus book called Calculus and was written by a man named Michael Spivak. Now, this book is very famous. It has a cult following because it has beautiful explanations. It does not have as much material, though, as some of the modern books. Partial differential equations, it's all out of order. So this is basically partial differential equations. In order to learn this, you have to know ordinary differential equations. And in order to learn that, you have to know calculus. So the order is calculus, differential equations, and then partial differential equations. They're called partial because they involve partial derivatives. Remember earlier I said derivatives describe the rate of change of a function. So partial derivatives are very similar, but you just look at the rate of change with respect to one of the variables in a multivariable function. That was a lot of information. Hopefully I did not misspeak. Then we have complex analysis. So when you study calculus, you deal with real numbers, right? You have functions that have real numbers. So here it's very similar, except all of a sudden you have complex numbers. But a lot of the same rules apply, right? Like all your derivative rules are the same. All the series stuff is the same. There's some really cool new stuff like harmonic functions and Cauchy's integral theorem. It's one of the really cool subjects. In order to get into this, you have to know calculus, and it helps to know some proof writing. Wonderful book, by the way, worth every penny. I love this book. This is probably my favorite. Calculus by James Stewart. Definitely the most popular calculus book in the world because it's used, definitely in the US and Canada, this is the most popular one for sure. Many schools use this book. I used a different version of this book when I took calculus. You could use this to learn calculus 1, calculus 2, and calculus 3. So in calc 1, you learn the basics of limits and integrals and derivatives, and you learn a lot of the key theorems like the mean value theorem, the intermediate value theorem, the first fundamental theorem of calculus, the second fundamental theorem of calculus. Calc 2, you do more stuff. You do some applications, infinite series, more integration. Calc 3, it's multivariable calc. So functional analysis. This is graduate level course here. You need analysis for this. You need algebra. You need topology. You need to know a lot of mathematics before you do functional, but it's really, really fun. I threw this in just for fun. This is a great calculus workbook that you can use to learn calculus like right away. Advanced calculus. So this is like real analysis. This is basically calculus with proofs. So we talked about how calculus has limits and stuff like that. So here you prove everything. So this is something that requires knowledge of calculus and proof writing, okay? And this is probably the hardest subject on undergraduate studies in the US. Like some people might say it's algebra, some people might say it's topology. I think that advanced calculus is by far the hardest subject an undergraduate math major has to get through. It's also called real analysis, by the way. Another complex variables book. This is one of the first ones I ever purchased. Another analysis book. This is the one by Apostle. This one's really hardcore. Numerical analysis. Here we go, a different subject. So numerical analysis is like analysis, basically, but you're doing approximations. So you can take a whole course on this stuff. You do a little bit of numerical analysis and differential equations, but you do a lot more when you take an entire course. Another book on partial differential equations. What's this? Ooh, Hilbert space. Yeah, you need to know topology, analysis, all that stuff for that. Fourier series, same thing. You want to know a lot of calculus. You want to know how to prove things. It's just messy. This falls under like applied math, by the way. I know I didn't break it up into pure and applied. So a very famous book, it's called Principles of Mathematical Analysis. It was written by Walter Rudin. So this is an analysis book or an advanced calculus book, but people call it an analysis book. It is called mathematical analysis. In any case, you'll smell it. This book has really hard examples and really hard exercises, and it's very famous. I like the book by Buck better because it has more examples. Regular differential equations, right? So I'm going out of order. So regular differential equations, you can learn that after you know calculus. And then once you know this, you can learn differential equations. So differential equations, you basically study these equations, like this one here. Let me show you. And you have to solve for dy dx. dy dx is the derivative of the function. So no, you have to solve for y, which is the function. I misspoke. So you have an equation involving an unknown function y and one or more of its derivatives. That's the definition of a differential equation. dy dx is the derivative of y. And so basically, you have to solve this for y. So there's usually procedures that you have to do in order to do that. It's not like you just like use algebra to solve, because you have to get rid of the dy dx, right? So you learn techniques. This one's a Bernoulli differential equation. Those are really fun. Yeah, I have some videos here on my channel of Bernoulli differential equations. And then analysis, another book on analysis. I wanted to include this one. This one has less content than the other analysis books you've seen so far in this video, but it has better explanations and it's easier. So it's really good for beginners. All right, let's keep going. We've got 3 more categories to go through. Here's an area that I feel doesn't get much love from people. It's probability and statistics. I feel like most math majors I've known aren't really into this. And the people who are into it are very much into it. Keep in mind, you can get an entire degree in statistics, right? So it is almost like a separate field, but it is part of mathematics, so I wanted to include it. So probability and statistics is our next category. And I have way more books than this, but these cover pretty much the core things. So here's a mathematical statistics book. This is something you would take as a math major or as a stats major. As a statistics major in college, this is probably the hardest course you take. So mathematical statistics is basically statistics where you prove everything, right? And everything's a little more rigorous. And what is statistics, by the way? Well, in statistics, you go out, right? And you're trying to say something about a population. This is just one example. And what you do is you take a sample, which is a subset of that population, and then you can do things with that sample, right? You can estimate the population mean, or you can ask questions about the population mean. Is the average age of people in this area greater than 40? And you can do like a hypothesis test. So there's different ways of applying statistics to the real world. And I think that's really, really cool. And I think people should care more about it. But I think now data science is the thing. But yeah, that uses statistics. Here's another mathematical statistics book. Excellent book. This is one I used. And then here is an easier one. This is a good one. This is one that I actually used to teach in college a long time ago. So I used this one for a few semesters and then we switched books. But this is the one by Brass and Brass. It's a solid book. And this one has really good explanations. Like it'll teach you statistics. It'll explain, what is a confidence interval? How do you interpret confidence intervals? How do you interpret a hypothesis test? And all the other basic stuff like probability and stuff like that. By the way, this book has probability in it, right? So probability is another subject. Another basic stats book, very similar to the Brass and Brass one. A mathematical statistics book, and again, this also has probability in it. This one, again, would be for math majors, whereas these two here would be just like the general public. So like, if you just know basic algebra, you can jump into these books. Whereas these mathematical statistics ones, they do require some basic proofwriting and some knowledge of calculus. However, you could, in theory, jump into this and then when you get to the calculus, you just skip it. So not everything requires calculus. And this one, again, it's more probability and statistics, but this one is specifically for engineers. So very similar to the mathematical statistics books, these books. And these are typically used in college by people who are studying engineering. Okay, typically they are required to take some course called like statistics for engineers. And those courses are okay, but the better course is the math course. Like usually the one by the math department is more rigorous because it's taught by a statistician or a mathematician. A lot of times, I think the people who teach these are just like, I'm nothing against engineers, but they're not math people, right? So I don't want to get any hate in the video, but I just think it's a little bit harder. Like this is a harder class. Like if you take mathematical statistics in college, it's going to be harder than stats for engineers. This is going to be way harder. This is way harder. I know I took 2 semesters of it, and I've seen what's taught in this because I've had students who have taken this class, and it's hard. So level of difficulty would be, in case you're curious, so easiest, and then harder, hardest, right? That's my view on the stats hierarchy there. Feel free to disagree. All right, let's go to the next subject, applied mathematics and modeling. So this could really fill an entire room of books because there's so much applied math out there and there's so much modeling. So I decided to throw physics in here. I thought physics, let me throw this in here because it's applied math. I mean, people might say, well, it's physics, it's not math. I mean, you use a lot of math and it's applied. So I decided to throw in physics, and this book here is wonderful. This is the one by Halliday and Resnick. Great physics book. The prereq is calculus, by the way. You got to know calculus. An advanced engineering mathematics book. So this book actually contains linear algebra, differential equations, calculus, complex variables. It has a lot of material. It gives you a rough overview of everything, but it's advanced engineering mathematics, so I wanted to throw it in with this stack here. Wonderful book. The worst thing about this book is the price. It's never cheap because it's always in demand. That's true for a lot of books. Some books are just like always expensive because people want them. I thought I would throw in an electrical engineering book. I mean, sure, it's a different field, but it is an application of mathematics, right? We use math in all areas. I mean, math is so prevalent, right? So physics, engineering, I mean, they all use math, right? Cryptography actually uses for a course. Yeah, our teacher went through the entire book. We went through the entire book. It was completely insane. I remember being so lost because we were covering so much. It wasn't hard. You know, it takes effort. There's a lot of like algorithms and procedures you have to learn. But when you go through the whole book, that's pretty intense. But beautiful subject. The prereq for this smells great. I guess it's nothing. I mean, it helps if you know how to write proofs and you had some other math in your life, like, you know, you have some foundational math. But you can see it starts with classical crypto systems, and it goes through, just gives you like some simple examples. It does talk about digital currencies, but this book was written before the existence of Bitcoin, so you get a pre-Bitcoin introduction to digital currency, because Bitcoin didn't exist, right? People don't realize how big of a deal it was when it was created. So, so this book was created before Bitcoin, so it does not cover that, but it does have a chapter on digital cash. So it does cover it, but again, it's pre-Bitcoin. Physics, again, this is specifically modern physics. I actually use this for a course in college called Physics 3. Really beautiful subject. You do some of the stuff with Einstein in there, like you do like relativity and stuff. So time dilation, pretty fun. And another physics book. I thought physics deserves another book here, so I threw in physics here as well. And there's more specific subjects within the category of applied math. But again, you can take any subject, any math subject, and it'll fit into this category, and you're there. But chaos theory, etc., all kinds of stuff. All right, let's go to the last category, advanced topics and frontiers. So this is basically things that were advanced that I didn't decide to fit into other categories. Certainly there were some books, some of the categories that fall into this category. There's plenty of books here that were very advanced that one could easily put into this category, but I decided not to for whatever reason, and I've got 2 really strange books on topics that you've probably never heard of. And by frontiers, you could throw in anything new. Any type of new mathematics would go in here, like, you know, research mathematics, any papers, you know, you could put those in here, and that would be an example of frontiers. So combinatorial topology, here's a really old book on combinatorial topology. You've probably never heard of this. Super advanced stuff, right? This requires tons of mathematics, right? Topology, combinatorial, everything. You just have to know all the core areas, analysis, algebra, topology, counting. I mean, you have to know a lot, right? You have to know a lot of math to do this. And then this one here is really weird. Piecewise linear topology. This is probably something you've never seen. Again, super, super advanced. What's it say here? Fx sub 0 through x sub r are points in n-dimensional Euclidean space, e to the n. We say that they're linearly dependent in the affine sense. Okay, yeah. Yes, this is some linear algebra they're reviewing. Yeah, but it does, I mean, it just jumps into it. As you saw, it's pretty hardcore. I promised you a book at the end that covers a bunch of topics. So I have it here, and it's called All the Math You Missed But Need to Know for Graduate School. It was written by Thomas Garrity. I interviewed him a long time ago for the channel here. And I really like this book a lot. So you can see Here's a brief summary of the topic. So we covered a lot of these topics already in this video, right? Look, linear algebra, real analysis. Here's some more math, right? So very specific, right? Differentiating vector valued functions. That's analysis, topology, analysis, geometry, countability and the axiom of choice. That would be foundations of mathematics. See, so there's lots of, these are subtopics, right, within these areas. Like, so a lot of these books cover these things, the books I've shown you, right? So this is a cool book. And so how it works is, let me show you. Look at all that. Zoom out so you can see better. So let me show you how it works, how he, so you go to the section and basically, like, look at point set topology. So the basic object, topological spaces, basic map, continuous functions. And he goes through and like he teaches you mathematics, right? Like he teaches you math. And he does it in a really good way, and it's to the point, and I'm sure he struggled to make it clean and short because, you know, he wants to fit all of this in one book. That is a monumental task, right? It's a lot of subjects in one book. He covers all the key theorems, or a lot of them, right? And then you've got some exercises there at the end. So, I mean, pretty incredible. I have to smell it. I love this book. Ah, amazing. So I'll definitely leave a link to this one in the description of this video in case you want to check it out. So yeah, that's it. That's all of mathematics, right? 8 categories. And I think you can fit every single math subject into one of these categories, right? We had analysis and calculus. We had probability and statistics, right? What else did we have? We had discrete mathematics and combinatorics, right? That's for like computer science majors. Geometry and topology. You know, you don't do a lot of geometry in college. Like there's a geometry course is not a course that many people take in college for some reason. Typically, people who take geometry courses are math education majors. That's usually a prereq for the math education degree. All right, so we have all the topics. We've got analysis and calculus. We have advanced topics and frontiers, geometry and topology, probability and statistics, discrete math and combinatorics, foundations of mathematics, and then the last one, oh, a couple more, algebra and structures, and then applied mathematics and modeling. So those are the 8 categories, 1, 2, 3, 4, 5, 6, 7, 8. Yep, they're all there. So those are the 8 categories that I was able to create, and yeah, that's all the areas of math, right? You can throw in anything into one of these categories, and if it's really advanced, you can just throw it into the advanced topics, and if it's new, you can throw it into the frontiers. So yeah, that's pretty much everything. Yeah, that's it. Hopefully you enjoyed this video and you have an idea of all the areas. I know it's a lot to fit into one video. It's just like, I can't imagine you know, him writing the book. Yeah, really, really tough. As always, subscribe if you want to and all that stuff. And, oh, if you want to learn math, I have courses, right? I do have courses. They're on Udemy. But if you get them, use my links. They're in the description of this video, or they're on my website, mathsorcerer.com or freemathvids.com. When you use my links for my courses, it helps me and it helps you because I lowered the prices, so you should get a low price. I've got courses on trig, college algebra, Calc 1, Calc 2, Calc 3, differential equations, abstract algebra. I have a course on analysis. I have some courses that have some proofs and stuff. So yeah, check it out. Check out the links from my website. But the key takeaway from this video should be that there's all kinds of math out there, right? So yeah, take care and keep doing math.